Now let's try to find number of relations which are irreflexive. Okay, so before that, let us assume that we are talking about relations which are subset of A cross A and mod A equal to n, I mean cardinality of A equal to n. So now I want to find out the number of relations which are irreflexive. So the number of I want to find out the number of irreflexive relations. Okay, now how can we do that? So we know that the total number of elements in A cross A are going to be n square. So let me just enumerate them, then you will understand it. So all the elements of A cross A will be of two types. One is diagonal elements and the other is non-diagonal elements. Diagonal elements will be of form x comma x, which means I'll have 1 comma 1, 2 comma 2, 3 comma 3, so on, n comma n. These are all the diagonal elements which will be present in A cross A, as well as other elements like this 1 comma 2, 1 comma 3, so on. Right? These are all the non-diagonal elements. Now we know that the total number of elements that will be present in A cross A is going to be n square, and the number of diagonal elements is going to be n, and the number of non-diagonal elements is going to be n square minus n, isn't it? Total minus n. Now if a relation has to be reflexive, if I have to form a relation which is going to be reflexive, definitely I should not have any of these elements. I don't want all these elements. Therefore we have to completely ignore them, neglect them, or remove them. So we should not consider them at all. Now from the remaining elements only we have to form the relations, and those relations are going to become irreflexive. Now if you consider the remaining elements, how many are there? N square minus n. Now for each of these elements we have two choices. Either we could include them or we may not include them in forming the relation, new relation, right? Therefore each element is going to have two choices. Either we include them or we don't include them. So with these many choices, right, how many elements are there? N square minus n elements. The total number of relations which can be formed using only the non-diagonal elements is going to be 2 power n square minus n. Got it? So this is the total number of irreflexive relations possible. Now if you remember it, even when we are trying to find out the total number of reflexive relations, we got the same answer. Why? Because we include all these elements in the relation, and then apart from this we were discussing about the remaining elements, and again the same way each element can be included or it cannot be included. Therefore we got two choices for the remaining elements, and how many were there? N square minus n. So we got the same one, 2 power n square minus n. Right? Now we know that, so this is the answer, that is final, which means the number of irreflexive relation is this. I am just trying to solve other question. So the other question is, now we know that the number of reflexive relations is going to be 2 power n square minus n. I already discussed this. And the number of irreflexive relations is also going to be 2 power n square minus n, right? So what can you say about this? How can you picturize them? If this represents universal set or the set of all relations possible, then the number of reflexive relations is going to be this, and the number of irreflexive relations is going to be this, and there will be no intersection at all. Which means if you put all the reflexive relations in this, and if you put all the irreflexive relations in this, there will be no intersection. But then there will be some relations which are possible outside. So this is the set. These are the relations which are not reflexive as well as not irreflexive. Now there are various kinds of questions possible on this. One is, what is the total number of relations which are either reflexive or irreflexive? Say this. What is the number of relations which are either reflexive or irreflexive, right? Which means I want to find out the number of elements present in this as well as in this. Now we have just found out that the number of relations which are reflexive is this and which are irreflexive is this. Therefore the total is going to be 2 into 2 power n square minus n, which can also be written as 2 power n square minus n plus 1. This is the total number of relations which are reflexive or irreflexive. Now one more question is possible. What is the total number of relations which are neither reflexive nor irreflexive? Right, which means they are asking about the relations which are present outside. They are not reflexive nor this one. So how can we find out? So total minus reflexive or irreflexive, isn't it? So it is going to give us the relations which are neither reflexive nor irreflexive. Now we know that the total number of relations is going to be 2 power n square. From this I am going to subtract the relations which are irreflexive or reflexive. So which is going to be 2 power n square minus n plus 1. Got it? So this you can write it like this. Okay, you can leave it there, right? So now this is how you can find out the relations which are neither reflexive nor irreflexive. Okay, so one other way of finding out the relations which are reflexive, which are neither reflexive nor irreflexive is, see this. Now we know that a relation is not going to be reflexive nor irreflexive if it contains some of the diagonal elements but not all of them. See this, if I include all this, then it is going to be reflexive. If I don't include all of this, it is going to be reflexive. But then if I include some of this, then it is going to be neither reflexive nor irreflexive, isn't it? So now let's try to form all the using these n elements, using these n diagonal elements. If you try to form all the subsets possible, then we are going to get the cases. How many cases? 2 power n subsets are possible, isn't it? If you include each element, an element can be present or element may not be present. If you try to form all these subsets, then we might end up getting 2 power n subsets, right? But then if this relation, if that subset has to be in such a way that it should not contain all these elements or it should not contain none of these elements, which means from the subsets possible, okay, it is getting difficult here to explain. What I am trying to do is I am trying to derive the same answer using some other method. Okay, for this method, the explanation I am trying to give you is this: a relation is going to be, if a relation has to be not reflexive and it has to be not irreflexive, then you should not contain all of this or it should not contain none of this. It should contain only some of this, isn't it? If a relation contains all of this, then what happens? It is going to be reflexive. If a relation contains none of this, then it is going to be reflexive. Now we have to eliminate these two cases. Now I want to form all the subsets possible from these n elements. Okay, now from these subsets possible from these n elements, I want to eliminate two cases. What are the cases? I don't want to include all of this or I don't want to include none of this, right? So from this 2 power n, I am subtracting these two cases. Try to understand this simple logic. What is it? Using these n elements, I can get n sub 2 power n subsets. From these 2 power n subsets, I want to eliminate two cases. What are the two cases? The case in which all the elements will be present and the case in which none of these will be present. Why? because if I include all of this, it is going to be reflexive. If I include none of this, it is going to be irreflexive. I don't want to make these two sets. That is why I am removing those two cases. So what is it? Using these n elements, the number of choices we have is 2 power n minus 2, and from the remaining n square minus n elements, we don't have any restriction. You can include them, you can include them, or you may not include them, or they are all going to be free. Therefore the remaining n square minus n elements is going to give me these many cases. I don't know if you are understanding this or not. If you are not understanding this, then better go with this method only. If you can understand it, just try to understand this one. Okay, so this is the answer. One other way of deriving it is this, right? So what did I try here? Simple logic. Let me explain you again. So using the first 10 elements, these diagonal elements, I am trying to eliminate just two cases. One case in which all of them are included, and the other case in which none of them are included. Therefore I got 2 power n minus 2, right? And from the remaining elements, they may or may not be included, and there is no restriction on that. That is why 2 power n square minus n. Why n square minus n? Because the remaining elements are going to be, the total number of elements are n square minus n, right? Now if we expand it out, then we are going to get, it is 2 power n square minus 2 power n square minus n plus 1. Got it? The same as that. So if you didn't understand this, better go with that. How did we derive this? We have found out the total number of reflexive relations, and we have found out the total number of irreflexive relations, and we have added them both, and therefore I got it. See, one more thing. If A represents set of all relations which are reflexive, and B represents set of all relations which are irreflexive, then when I asked you for A union B, right, n of A union B, we have here applied the case that n of A union B equal to n of A plus n of B, right? But then we didn't subtract n of A intersection B. I directly found out that this number is going to be 2 power n square minus n, and this number is going to be 2 power n square minus n, but then I didn't subtract A intersection B. Why? Because this number is 0. The number of relations which are both reflexive and irreflexive is 0. That is how I directly got this number to be here, right? And from total, when I subtracted this, I got the relations which are neither reflexive nor irreflexive. That is one way of doing it, and the other way of doing it, if you can understand, it is this way. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177, and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days. and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.